there's a lot of really interesting developments happening in the X11 world. Obviously, we have Xlibre, the fork of the Xorg server, which ruffled just a couple of feathers. There is Phoenix, a new X11 server written in Zig. Then you have Y server, a X11 server written in Rust, and Frame, an X11 server written in assembly. Do note with these last two, there is Claude here and there is Claude here. Now, whether or not that is something you care about or you don't care about, that is totally up to you. But do note both Y server and Frame do make use of AI, and you're gonna probably have new servers that come along that do the same as well. But that is not everything. There's also been interesting work in the world of X11 compatibility running on top of Wayland. Obviously, the main thing people use is Xwayland. This takes the Xorg server and basically integrates it into your Wayland environment, whether that be KDE, GNOME, Hyperland, River, Mango WC, pick your poison, and this is what most people are using. But some environments choose not to support Xwayland. Neri, for example. In Neri, if you try to run an X11 application, there's no Xwayland there. That's just not going to work. Instead, it relies on an external implementation known as Xwayland Satellite. This is the direction that I kind of expect a lot of new environments to end up going that just don't want to deal with the hassle of Xwayland. However, we also have a project known as Wayback. This is less about individual applications and more about entire desktops. This allows you to take an old desktop like, say, Trinity, for example, or Awesome WM, and then run that through Xwayland so you don't have to just keep that, like, traditional X11 software around. This is super cool, but it's also not really inventing the wheel. It's basically just taking tech that already exists and then making it more convenient to use. In a sense, it's kind of like Zinc, which is OpenGL running on top of Vulkan. Albeit, OpenGL on top of Vulkan actually runs faster than native OpenGL. This one, not so much. However, there is also a slightly newer project as well, and that's what I want to talk about today. That is Libx11 Compat. Wayback already had a very niche goal. Most people do not care about the idea of taking an X11 desktop and then running it on Wayland. They're just going to wait for it to natively support Wayland. This, however, this is even more niche. This is something where most people are not even going to remotely care, but I think it's really cool. Libx11 Compat is an in-process implementation of the X Window System client library Xlib layered on top of SDL. SDL is a common library used in various things like game development and other things like that. I did not know that a Danganronpa game was made in SDL. That's cool. SDL TTF and Pixman. It lets Xlib clients keep their source unchanged while running on platforms where a conventional X server is unavailable or inconvenient. macOS without Xquartz, Wayland-only sessions, headless CI, Android apps with their own SDL integration, and similar environments. The library is not a reimplementation of the X11 wire protocol and does not replace a real X server. Its goal is to keep legacy Xlib code building and running while it is being migrated to a different toolkit or display stack. This is a fundamentally different approach from what we've seen with regular Xwayland, with Xwayland Satellite, with Wayback, because all of those, they are X11 servers. Xwayland is an X11 server. Xwayland Satellite is using the same tech. Wayback literally just builds off of Xwayland. All of those are full X11 servers. They can do the full things that X11 servers can do, even things that you probably don't want to be doing in the modern era. This, though, Libx11 Compat is not that. Instead, what it does is basically takes Xlib and then runs it inside of this SDL container. The SDL container is a native Wayland window, right? That's totally fine. Wayland sees it as Wayland. It thinks it's Wayland. Wayland all the way. But inside of that container, inside of that, it is running the X11 Xlib library as if it was always made to be on Wayland. Rather than having a whole X11 server there, it's treating the library as sort of like just supporting Wayland out of the box. I have absolutely no doubt that random little things are going to break because of this, because a lot of things are built around the way X11 worked. A lot of things really, really rely on there being an X server, or fundamentally just are weird. And trying to run some of those applications on Xwayland, even though it is an X11 server, is sometimes going to cause problems because they don't expect there to be this other thing that is handling the placement of windows, handling this, handling that, and it causes problems. So random order applications do tend to break in Xwayland. It's usually pretty good. But for those ones that don't work in Xwayland, possibly this could be another approach to dealing with those. Not everything, but some of them, and maybe. And I like the idea that someone is trying it. If this was just a theoretical idea, maybe this could possibly work. That would be neat. However, it's a bit more than that. Several ports beyond the bundled demos now provide high-value integration coverage for Libx11 Compat. They are still compatibility workloads rather than daily use application ports, but each exercises behavior that small examples do not reach. There are quite a lot of examples here. We're not going to go through every single one of them, but I will leave the repo linked in the description down below. Motif. Upstream Motif and its demo suite build against the compatibility libraries, menu posting, pointer grabs, focus changes, text rendering, resource lookups, and selected demo workflows all work. Some widget paths still expose layout artifacts or map/expose propagation gaps that require full work. Motif's GLW OpenGL widget path runs too. The classic paper plane demo, that being this one right here, drives a GLW drawing area through the in-tree GLX over EGL layer, so live Motif menus and an animated 3D scene rendered together with no X server and no desktop GL driver. Many, many years ago, Motif was an incredibly popular library. It was what was used to build CDE, the common desktop environment. CDE is what directly inspired KDE, and whilst it is a bit more colorful here, a lot of those applications that you would see that had very square interfaces, square buttons, everything was gray, a lot of those were either built with Motif or libraries heavily inspired by Motif. On the topic of Motif, voila, www. The 1992 era Motif web browser builds and runs out of the consolidated build tree, loads HTTP pages over the network, renders inline XPM images through Libx11 Compat, and handles scrolling, resize draw, and the help menu. Recent fixes corrected sale glyphs after wheel scrolling, scrollbar dragging, and resize reflow. HTTPS, complex modern HTML, and several interactive flows are known limitations of the application rather than the compatibility layer. This is a browser from 1992. Don't expect the modern web to function on it, but there are pages out there that will still function. There is also a fork of the Mosaic browser which still exists. It loads HTTP pages, lays out inline images and tables, and handles initial paint, scrolling, hyperlink navigation, and URL field editing, and of course, being a browser from 1993, the modern web mostly doesn't work, but again, there are pages out there which do. Osiris. This is a fork of Qt 2.3.2. This is still being maintained to this day. You might think that is weird. Why would anyone be doing that? The developer of this is doing it to take KDE 1, port it to Qt 2 to get some basic niceties like scroll wheels working and things like that, and basically have KDE 1 be a maintained desktop, because why not? Why not? Anyway, this fork builds against Libx11 Compat, Libext Compat, Libxmu Compat, and the link-only Libice Compat and Libsm Compat shims. This is the Qt 2 validation target and exercises widget stacking, pop-up menu placement, font metrics, timer delivery, expose handling, event loop responsiveness, and Qt designer behavior. The in-tree build disables Osiris XFT, OpenGL, SM, MNG, and the GIF feature probes so the default dependency boundaries stays SDL2, SDL2 TTF, and Pixman. GIMP 0.54, the 1996 release, the first public release of GIMP. I did a video on this a couple of weeks ago. This is something that somebody has gone and just slightly modified and patched to make it work on modern systems, and you can run it through Xwayland. But it also works through this. The last GIMP built on the Motif toolkit before the project moved to GTK, built against the Compat stack plus the handle motif. It is a full image editor that drives XCreateImage, XPutImage, XGetImage, the MIT SHM canvas path, true color 32 BPP visual and color map handling, large motif dialog and menu trees, and forked image format plugins that talk to the core over pipes and sysv shared memory tiles. XMMS, a very, very old audio player, the 1.2.x audio player, a GTK1 Winamp style workload built against the Compat stack alongside the ported GTK1 fork. It exercised the shape extension that skin players rely on. The main window, equalizer, and playlist are non-rectangular, so bounding mask hit testing routes pointer and focus events only on the visible pixels and lets clicks fail through transparent corners, skin pixmap loading, window dragging, the menu and equalizer playlist toggles, WM delete window shutdown, and on macOS audio playback through the core audio plugin all work. The main window, equalizer, playlist, and menu states are covered by the replay smoke tests. And Micropolis, the GPL release of the original SimCity engine, a TCL-X/TK workload that is a library that depends on, built together with a private copy of TCL/TK, so the port ships its own TK rather than relying on a system installed one. It is the toolkit MIT SHM workload, the tile map and editor views upload the pixels through XSHM PutImage, so the port drives the shared memory image path, and the 32 BPP XPutImage image transfer end to end. The value of these ports is not they replace a real X11, Motif, or Qt installed today, but that they keep legacy Xlim clients building and running on platforms where no X server is available while migration is in progress. So the end goal of this project isn't necessarily to be the infinitely long compatibility layer. However, it also does act like that, and for me, that is really cool. These ports rely on community input. Concrete reproducers, screenshot diffs, and small fixes posted to GitHub issues are the most effective way to push these workloads forward. Specific gaps worth opening issues for include widget paths that misrender, motif demos that crash or differ visibly from the native baseline, Osiris/Qt2 menu or designer interactions that differ from native X11, voila www interactions, navigation, dialogues, image formats that do not behave as the historical browser did, Xfig drawings whose objects rasterize differently than under a real X server, because doing it through this method is gonna cause some problems. There's gonna be some weirdities, there's gonna be some oddities where even though it looks like it is working, it's not really running it natively. It's running it in this pseudo-native Wayland state, which is not something any of these projects ever expected. Most of them predate Wayland by like 20 years. Whilst Xwayland obviously makes the most sense for the majority of people, I'm always fascinated by the fact that there's all of these different approaches that are out there to effectively solving the same problem. Now, ultimately, the goal is things to run natively on Wayland. That's what's happening in the gaming space. Now in the gaming space, you don't necessarily have to use Xwayland to play your games, but there's a lot of things where there's just never going to happen with. So having something there, having something, and having these different approaches that may be better or worse for different kinds of applications, personally, I think is neat. So let me know your thoughts down below. Is this something you would care about? Is this something you would use? Or do you just think it's kind of dumb? Anyway, if you liked the video, go like the video, go subscribe as well, go hype if you're on mobile, and if you really like the video and you want to become one of these amazing people over here, check out the Patreon, subscribe, Silly Pay, linked in the description down below. That's going to be it for me, and X.